Tony, they give me a picture for, so I just kind of drew that picture. This is going to be a right angle here. It says an airplane flying at an altitude of 6 miles. So is this 6 ever changing?
No.
No. So I'm going to write it as 6, not a variable. Okay, if it's something that changes, you put a variable in that spot, but it's always 6. Then it says passes directly over a radar antenna when the airplane is 10 miles away. So when S is 10, so I'm going to write that over here. That's what we're going to be plugging in. The radar detects that the distance S is changing at a rate of 240 miles per hour. So what's that 240 equal? dsdt. It's the rate of S, it tells us. So any questions on that? What? 240 was in miles per hour. So I'll write it here, that way it's easier to find our label at the end. Now it's asking, what is the speed of the airplane? So what are we trying to find? dx dt, right? Because the speed of the airplane's here, and this is how fast they're going, is the rate of x there. So how can I relate those variables to each other?
Pythagorean theorem.
Yep, so what's my Pythagorean theorem going to give me?
S squared equals x squared plus 6 squared.
Does that look okay to everybody? Then can we take the derivative of that and start plugging things in there? So the derivative of s squared is 2s ds dt. And then x squared is?
2x dx.
There we go. And the derivative of 6 squared is? 0. So I don't even need to write that part. Now if I try to plug things in here, I've got s is 10, so I'm going to be putting 10 in this spot. I've got ds dt is 240, so 240 goes in here. And to find dx dt, don't I also need x?
Yeah.
What is x? How can I find it? Pythagorean theorem. If I know s is 10 at this spot, can't I put 10 in this spot and then find this? This is the 3, 4, 5 triangle. Only it's doubled, so it's the 6, 8, 10 triangle. So x is actually 8 here. Or just use Pythagorean theorem and yeah, find it. And then you guys should be able to finish that. What's your label going to be if it's asking for the speed of the airplane? Miles per hour. So go ahead and find what you get there, and your label is going to be miles per hour. You need to label your answers, okay? 18 and 20 are pretty close to the same. Yep. Number 10 tells us it's a volume. It says the radius of a right circular cone is increasing at a rate of 2. So what's increasing at a rate of 2? What does it say? For number 10, what's increasing at a rate of 2? The radius. So what am I going to write that down as? dr dt. So I know dr dt is equal to 2. Okay, it tells me that piece. Then it says the height of the cone is related to the radius by h equals 3r. So I'm going to be using that here. Find the rates of change of the volume. So what am I trying to find? What's the rate of change of the volume? How would I write that? dv dt. Good. So I need to find an equation for volume that's in terms of r. So if I'm talking about a right circular cone, that's just a cone that comes to a point. If you are ever finding the volume of something and it comes to a point, that's beautiful. It's 1/3 of if it just came straight up and was like a can shape here. So what would be the volume of a can? How do I find that? I do the area of the base, which is pi r squared, and times by the height. So what am I going to put in instead of height here? 3r. That way it's just in terms of r. Otherwise I have too many variables going on. So I'm going to put 3r in this spot. So I have 1/3 pi r squared, and then I have 3r. What happens, so I can clean this up? The 3 and the third cancel, and then the r turns into pi r cubed, right? From there, can we finish this problem? So we can finish 10 from there. Okay, if you're given something like 22 on a test, and you have no idea what you're supposed to do, you know this is one of these related rates problems, right? What do you always have to do with related rates? What's this entire chapter on? Derivatives. If you have no idea what to do, maybe, take the derivative would probably be a good idea. So here it tells us for 22, a retail sporting goods store estimates that weekly sales S, so S is our weekly sales, and weekly advertising costs are X. They're related by this equation. It says the current weekly advertising costs are $1,500. So what equals $1,500 right now? The advertising cost, which is my X, right? So I know X is $1,500. And it says these costs are increasing at a rate of 125 per week. So what is that piece? dx dt, right? The costs are increasing at that rate. And that was 125. So any questions on where I got this? Because you want to put down as much info as you can as you're going, in case you don't end up getting all the way through the problem. So could everyone come up with these if it's on the test? Okay. dx dt, it tells me that the costs are increasing at a rate of 125. And I know my costs are my x. So dx dt, whenever it's increasing or decreasing, that's a d something dt, okay? Now I want to go ahead and take the derivative. So let's go ahead and take the derivative of this. What's the derivative of s? ds dt. And what am I looking for? Find the current rate of change of weekly sales. So aren't I looking for ds dt in the end? That's what I'm trying to find. So just keep that in mind, that this is what I'm trying to find. What's the derivative of 2250? 0. Derivative of 50x? 50 dx dt. And the derivative of 0.35x squared?
0.7x dx.
There we go. And plug in what you know, and you're good to finish that problem up, okay?